Good afternoon, everyone, and thanks for the opportunity to provide a quick report on the workshop we organized earlier this year. As you can see, the title is pretty long. I'm not gonna read the whole thing, but the objective of the workshop was to gather a group of experts who had either previously used large-scale testings or have interest in utilizing the larger scale testing to study SSI phenomenon. And the workshop was for 2 days, May 17 and May 18. I would like to acknowledge DOE and the peers for funding the workshop. I want to take a moment and specifically thank peer for the great support. From very early stages of planning all the way to the completion, and just frankly speaking, organizing such a workshop wouldn't have been possible without peers' great support. I also wanted to thank the organizing team members. We had a relatively large group from diverse backgrounds, from universities, industry, national labs. We had a couple of international experts also on our team. The initial announcement of the workshop was released through peer newsletter March 3rd, and I had personally reached to some potential presenters even before March 3rd. And then the abstract submission website was opened March 12th, and then the due date for submission was March 5th. In total, we received 27 abstracts, and those abstracts were organized into 8 sessions, 4 sessions per day. In total, we had 75 participants attending and presenting, which in my opinion was a great number considering the fact that the workshop was by invitational. As a part of developing the program, we grouped those abstracts into different trusts, and among the received abstracts, a third of the abstracts were focused on R&D research, and 22% on larger scale testing, and about 20% on simulations and validations. We have we ended up having the 26 presentations in total, from which 23 were from the US, 2 from Japan, and 1 from Italy. Within the US, we had a pretty diverse group of presenters, from East University of New Hampshire all the way to, to Buffalo and Illinois, and you see a lot of concentrations on the west side, as expected. What was pleasant to see was participation from 3 major experimental facilities with the capabilities to do larger scale soil testing. Throughout the workshop, we ran several polls, and I have a couple of examples here. For example, in terms of the backgrounds, about a third of participants were they had a geotechnical background, and the remaining structural. And also, when they were asked about their familiarity with larger scale testing, about a third they said they are very familiar. But it was interesting to see that about half of the participants, they had a little or almost no knowledge in larger scale testing. So there was a goodwill in terms of learning about the testings and how it can be utilized. That was very promising. Since the workshop was held virtual, we put together a virtual tour of the new larger scale facility at UNR, and I'm gonna show the video. It's a relatively quick video, 4 minutes.
Welcome to the large-scale shake table facility in the Department of Civil and Environmental Engineering in the College of Engineering at the University of Nevada, Reno. The custom-built shake table was completely designed at the University of Nevada, Reno to specifically study the response of soil structure interaction subjected to earthquake shakings. The shake table is a biaxial table including yaw rotation, with a system of concrete buttresses, individual concrete blocks, and through compact V configuration of 8 actuators. It has 13 inches of stroke in each direction and applies 1.1 to 1.2 million pounds of force in both X and Y. The platen sits on a system of 8 hydrostatic bearings that ride on a thin film of oil that's 2,007 inch thick. This stiff film of oil maximizes capacity and is practically friction-free. The bearings are oriented on the perimeters of the shake table to maximize our ability to overcome the roll and the pitch moments coming down from the box. This perimeter configuration is optimal for our platen. The platen itself is 24 feet by 24 feet. Because of its size, it was fabricated in 9 pieces and assembled and welded over a 3 to 4 week period. Because of the power of the actuators and the tendency for platens to move at high velocity, the system requires a lot of hydraulic oil and flow. Our extensive and custom hydraulic piping distributes oil at a velocity of 40 inches a second, enough to handle most earthquake motions. The laminar soil box consists of alternating layers of rubber bearings and 19 steel frames. The orthogonal box is 21 feet across, 15 feet tall, and can hold 350 tons of soil. Because the soil box is built into 3 5-foot segments, the sections can be swapped to facilitate many different research ideas. At its base, the alternating hollow tube steel frames are heavier than those at the top. Similarly, the 408 rubber bearings begin with the stiffest at the bottom. As you go up, the stiffness decreases and the number of bearings per layer as well as their size changes. This arrangement accommodates changes in the stiffness of the soil. As a result, the box can achieve a 2% strain inside the soil. The orthogonal shape allows for the box to move in 2 directions while facilitating instrumentation in the corners. In addition to this bidirectional design, the angles at its bottom further engage the soil through shear action. Stiff rubber on the faceplates accommodates complementary shear, allowing researchers to reduce the zone of disturbance. On the outside of the soil box, K-knot frames ensure it stays straight during assembly while eliminating shear stress. A collaboration of the Department of Energy, the Lawrence Berkeley National Laboratory in Berkeley, California, and the University of California, Davis. The many applications of the large-scale shake table facility include research that is designed to enhance the seismic safety of DOE and nuclear facilities. As such, it supports the goal of the Department of Energy to develop natural hazard resiliency of DOE mission-critical facilities and secure public safety, and represents another avenue for the researchers to pursue multi-agency research that raises the bar for the field.
Just for the sake of time, I'm going to skip the full acknowledgement. All the presentation slides have been already uploaded on the peer website. If you go on the peer website under news and events, you see a link to DOE peer workshop. And then once you go there under the program, you see that all the presentation slides are available. And even a link to this virtual lab visit also is available on the website. So as a part of the project, we will be putting together a report which will be published through peer. And The report will include the abstracts, the slides, as well as key findings and all the discussions that we had during the workshop, and that is the plan. So with that, I would like to thank you for listening to the presentation, and I'm